Everyone, welcome to add-on. So now we are going to solve this question where we are asked to find the value of T1 and T2, which is nothing but tensions in the string. So let us see how we can solve the problem. So let us firstly draw the FBD of the diagram, which we have. So we have a downward force of 1.2 kilonewton, which is 90 degree to the horizontal direction, and we have a force T1 acting at an angle of 45 degree. We have a force T2 acting at an angle of 30 degree, and the angle between of two will be obviously 180 minus 45 plus 30, which gives you 105. And the angle between T2 and this force, which is W force, will be, this is 90, this is 30, so the total will be 120. And this angle will be 90 plus 45, which will be 125. Sorry, 135. 90 plus 45 will give you 135 as the angle between T1 and this W force. So let us see how we can solve this question. Similarly, which we solved the previous question, we need to apply Lami's theorem here. And Lami's theorem statement says, Lami's theorem says that the force will be proportional to the angle between sine of angle between the other two forces, which is nothing but the forces. Let us say we are calculating for the force W, then it will be proportional to the angle between T1 and T2. Similarly, T1 will be proportional to the angle between T2 and this W force. So whenever there is a force equilibrium of three forces at an angle, acting at an angle, you can just apply Lami's theorem to find out remaining forces from one forces given. So let us see how we can apply that. So firstly, we have T1 divided by sine of the angle between other two forces, which is T2 and W, and the angle will be 120, because 30 this is, and this is 30, this is 90, so it will be 120. This is T1, so the opposite angle will be 120, and we have this equal to T2 divided by sine of the angle between the other two forces, which is T1 and W, and in this case it is 135, is equal to T3, or let us say we can call it W, which is given in the question, divided by the sine of angle between T1 and T2, which is 105. So this is how you can apply Lami's theorem. Let us call it equation number 1. You can take out two equations from our one equation, which is nothing but T1 by sine 120 will be equal to W by sine of 105, and T2 by sine of 135 is equal to W by sine of 105. So this will be your two equation which you can take out from the one relation which we are deriving from the Lami's theorem. We have T1 value as sine 120 into W, which is nothing but 1.2 kilonewton given, divided by, let us say divided here, so we have sine of 105. You can just calculate it, and you can firstly convert this angle into acute angle. So what we have here is sine of 120 will be nothing but sine of 90 plus 30, which will give you cos of 30, because sine of 90 plus theta is cos theta. And we also have sine of 90 plus 105 minus 90 will become 15. So we have 90 plus 15, which is nothing but cos 15. So you can just write sine of cos of, let me just, so it will be cos of 30 divided by cos of 15 into 1.2. so the answer comes out to be, let us say, cos of 30 divided by cos of 15 into 1.2 will give you 1.075 kilonewton as your answer for T1. Similarly, you can solve for T2. So let us just rub this. We have T2 as sine of 135 divided by sine of 105 into W. Sine of 135 can be rewritten as cos of 45, and sine of 105 can be rewritten as cos of 15 into W, so which is nothing but 1.2 kilonewton. So let us calculate this also. We have cos of 45 divided by cos of 15 into 1.2, which will give you 0.878 kilonewton as your force for the T2. So as you can see, we have solved for both the forces T1 and T2 using Lam's theorem. This is how you can solve this question. So yeah, thank you.